Hello, we are going to be talking about the use of individual, centralized, and distributed control systems. The outline for our presentation, we have our introduction, and then we're going to be going over the definitions of individual, centralized, and distributed control systems. Then we're going to be giving us some examples of individual, centralized, and distributed control systems. Then we're going to talk about the advantages and disadvantages of individual, centralized, and distributed control systems. Then we're going to give a definition of a closed loop control system and then an example of a closed loop control system, followed by the advantages and disadvantages of a closed loop control system. Then we're going to conclude with our conclusions, and then uh, have our references listed at on the final slide. So, control systems play a vital role in the automation and regulation of processes across industries, from manufacturing and power generation to transportation and smart buildings. The structure and design of a control system directly impacts its performance, reliability, scalability, and ease of maintenance. Among the key architectures are individual, centralized, and distributed control systems, each serving unique purposes and offering distinct advantages. Control systems architectures. We're going to be focusing on three, which are number one, individual control system, and then we're going to talk about centralized control systems, and then third, we're going to be talking about distributed control systems, or DCS. So, in individual control system, by definition, an individual control system refers to a setup where a single controller is dedicated to managing a single process, machine, or function. Below, we have a picture of an individual control system, which is a conveyor that's controlling a process of product that's being uh, put in a system. And we also have our sensors that is going to detect where the process is, and then give an output on what to do next. Next, we're going to be talking about central control systems. By definition, a centralized control system is one in which a single central controller manages and coordinates multiple processes or devices. So as we can see in the picture, we have one central controller that's uh, controlling the outputs for our system, which could be, conveyors, or a continuous process. And we have the interfaces, which are going to be basically monitoring the process and what's going on, and giving you know uh, some better foresight into what's happening, into troubleshooting if the process has stalled or stopped. And now we're talking about distributed control systems, which by definition a distributed control system is a network of interconnected controllers, each responsible for specific processes or sections of a system. And we see here we have multiple controllers that's controlling different processes in a system, uh, giving different outputs from our field devices. We're having a priority right here as a continuous process, whereas it might be a conveyor controlling product to be uh, processed, and then after that, you know, one process is done, another conveyor will probably, you know, send the product to a destination where that product is going to go through the final stages, whether it be uh, put on a pallet or, you know, put into some type of container and be ready to be shipped or distributed. So the advantages and disadvantages of individual control systems. The advantages are the simplicity of the system is easy to design, understand, and troubleshoot. Cost effective for small systems, fewer components, and no network requirements. Another advantage is reduced risk of total system failure. A fault in one controller doesn't affect others. The disadvantages of uh, individual control system is the lack of coordination. No communication between devices can lead to inefficiencies, scalability issues, difficult to expand or integrate into larger systems, redundant resources. Each unit may duplicate control and monitoring resources. So now we're going to be talking about the advantages and disadvantages of centralized control systems. The advantages are centralized monitoring and decision making, easier to manage the whole system from one location, efficient coordination, meaning all parts of the system are synchronized, the simplified maintenance, one system to update or troubleshoot. Disadvantages are single point of failure. If the central controller fails, the entire system goes down. Another disadvantage is high communication load, whereas referring to all field devices must communicate with the central unit. And another disadvantage is less responsive to local disturbances, delay in reacting to site-specific problems. Next, we're going to be talking about the advantages and disadvantages of distributed control systems. The advantages are high reliability. Failure in one node usually doesn't affect the whole system. The scalability is another advantage. Easy to expand by adding more controllers. Another advantage is faster local responses. Local control loops handle issues more quickly. The disadvantages are higher initial cost. Dealing with more components and communication setup will lead to higher costs. Another disadvantage is the complex design and maintenance. Well, these systems will require trained personnel and documentation. And another disadvantage is network dependency. System performance depends on communication infrastructure, which is a disadvantage because if you know there's a problem with communication or the network, that is going to cause the whole process to stall or the whole system to fail. So now we're talking about closed loop control systems. By definition, a closed loop control system is a type of control system that automatically adjusts its output based on feedback from the actual output of the system. Here we have a continuous process whereas the input is given and the valve is uh, creating the right temperature and then given the tank, which need to be heated at a certain temperature uh, to complete the process. And then we have a pressure thermometer that's making sure that you know everything is all the pressure is uh, right in the system. If not, it's giving feedback to stop the process, or giving some type of input to the system on what's going on. So some advantages and disadvantages of a closed loop control system are: the advantages are automatic error correction, continuously adjust the output to reduce the difference between the actual and desired values. Another advantage is high accuracy and stability, which means it maintains consistent performance even under changing conditions or external disturbances. Another advantage is improved reliability, less affected by variations in load, environment, and system wear over time. Another advantage is self-compensating, automatically compensate for system changes or faults within limits. Uh, uh, Talking about like the speed, the temperature, and pressure, so it automatically adjusts and you know uh, to them type of errors that it might see to give a better performance. Better. Another advantage is better performance in complex systems. They can manage multi-variable and dynamic systems with precision. Uh, Talking about like robots and industrial automation. The disadvantages are higher costs, requires additional components like sensors, feedback devices, and complex controllers. Another disadvantage is complex design and maintenance, more difficult to design, tune, and troubleshoot compared to open loop systems. Another disadvantage is a risk of instability. Poorly tuned systems can oscillate or become unstable due to excessive gain or delay in the feedback loop. We also have another disadvantage, which is slower response time. The response time may be slower due to processing feedback and making corrective actions. And another disadvantage of a closed loop system is the dependence on sensors. Performance is highly dependent on the accuracy and reliability of feedback sensors. In conclusion, control systems are essential in managing and automating industrial and commercial processes. Three primary types of control system architectures are individual, centralized, and distributed control systems, each with distinct characteristics and applications. An individual control system uses a standalone controller to manage a single process or device, making it ideal for simple, independent operations. A centralized control system relies on one controller to oversee multiple processes, enabling coordinated control by posing risks if the central unit fails. A distributed control system spreads control across multiple interconnected controllers, enhancing flexibility, fault tolerance, and scalability for complex environments. Choosing the right architecture depends on factors such as system complexity, reliability requirements, and scalability needs. Understanding these systems ensures the design of efficient, robust, and cost-effective automation solutions. Thank you. And our last slide, we have our references. that we use to put this presentation together. So thank you for your time. And today we were talking about the use of individual, centralized, and distributed control systems.